Welcome, geometry students. This week, we're going to begin proofs, which are a big part of geometry. In this video, I'm going to introduce proofs using a program called ConfigureIt. The course has the class code. You'll need to create an account. I recommend using your school username and password. Once you get into ConfigureIt, you should see a class having a list of the proofs you'll have to do. Unfortunately, they're not necessarily in the order I want. We are going to start with the proof that's congruent parts of segments 1. Click on that to open it up. When you read proofs in your book or on a worksheet, the format might start a little bit different. Each proof starts with givens. That's information that you've been told. In ConfigureIt, they call it justified claims. That means we know this is true. We are told it. You can see there's a little present there. It was a gift. You were given it. If you want to see why these things are true, you can click on the Y button, and it will give you a more formal proof. Towards the center is unjustified claims. In other words, this is what we want to prove is true. So on a paper proof, this would be, it would say, given AC is congruent to CB, prove C is the midpoint of AB. In ConfigureIt, there are a couple different ways you can work on your proof, and that's going to happen here in the center where it says working on it. The first way is to start from a justified claim. This is what you would typically do in a proof. You would look at the given information and ask yourself, well, what does that mean? So we're going to click on this justified claim, and it moves it in the center. The nice thing about ConfigureIt is it lists different theorems that I can work with. So you can hover over the theorems, and it will tell you different information about congruent parts. And what you can do is you can look for a theorem that has information that you think relates to this unjustified claim. Now we want to prove that C is the midpoint of AB, so I'm going to look for one that talks about a midpoint. Oh, and there I find a point which divides a line into congruent parts is a midpoint. So I'm going to click on that. Now, in order to use this, we're going to have to fill in some steps. So we're saying that AC is congruent to CB. We'll submit that. Whoops, on my screen it's small. So that means we need to fill in something. Okay, so I'm looking at the picture now, and I know that AC is congruent to CB. If I click up here in the justified claims, it will show me the parts that are equal. But so that means then that C is the midpoint of AB. I can click submit. And you can tell we actually finished this proof. We're starting with some pretty short proofs that might just have 1 or 2 lines. As I said, ConfigureIt has 2 different methods for working with proofs. So I'm going to go back and I'm going to start over, and we're going to work in a slightly different way. The second method is to work from the unjustified claims, what we're trying to prove. In other words, here we're going to start and look at, well, what do I need to know in order to prove that C is the midpoint of AB? ConfigureIt's going to give me some options. Sometimes you might not yet have an option that fits, and we'll have to come back to it. However, in this case, I'm looking at the options and I see, oh, a point which divides a line into congruent parts is a midpoint. That sounds like that's going to help me out. So I'm going to click on that. And now I'm going to have to provide information to prove that I know that. Well, remember, we can use this stuff in the givens. So what I was already told is that AC, notice when I typed that in, it highlighted, is congruent to CB. Okay, so I'm going to type that in. That means that C is the midpoint of AB. Let's hit submit and see if that was enough information. Awesome. So again, we are done. If you wanted to look at the written proof, click back to your proof, click on the Y part, and that's what we have stated for our proof. So make sure you've completed this proof using one of my two methods. You don't need to do them both. Then click the home button to go back to our main screen. And the next one I want you to do is angle bisector. You're going to try this one on your own, but it's very similar to what we just did in number 1. This will save your work as you go. So make sure you go through all the steps until it says congrats, and then return back here. If you need more help as you're working, notice in the bottom left, there's a button that says stuck, and you can click on that, and it can give you some different hints. After you've completed angle bisector, return to this screen, and we're going to work on angles transitivity together. So in this proof, we are given that angle EDA is congruent to angle AED. You'll notice when I hover over them, it highlights the equal parts. We are also given that angle EDA is congruent to angle CBA. If you click on the justified claim, you're going to have quite a few different options that come up, but none of them really give me what I need. I'm going to notice though, I have two pairs of angles. Each of them is equal to EDA, and the title of this proof uses the word transitive. Transitive property is going to be used often in your proofs, especially at the beginning when we don't have a lot of different theorems to use. So transitive didn't appear as a list. I need to start by adding a new claim. When we make a new claim, we need to choose what type of object or element we're working with. Well, we're talking about angles. I know angles are congruent. I'm trying to prove them. Then I want to pick what I'm claiming. So what do I know is true? One thing to pay attention to is the difference between congruent and equal measure. Congruent angles have equal measures, and I'm pretty flexible about switching between them. CanFigureIt wants you to pay attention to what symbols you've given. So since I've been given congruent angles and I want to prove other angles are congruent, I'm going to choose the congruent angle part. Now, which angles do I know are equal? Well, since EDA is equal to angle AED, and angle EDA is also congruent to angle CBA, then that tells me that angle AED is congruent to angle CBA. I'm going to claim it and see if I can then justify that it's true. Okay, now I need to justify that it's true. Again, I can hover over and see some options. Reflexive, nope. Angles with equal measure, no, don't have that. Oh, transitive. If two angles are each congruent to a third angle, then they're congruent to each other. I'm going to click on that. Now I have to provide more details. So I need to show that those angles are each equal to the same angle. So I know again from the justified claims, and I can even hover up here and it shows what I could fill in. Angle EDA is congruent to angle AED. And I can do the same with the other justified. So angle AED is equal to angle EDA. CBA is also congruent to EDA. So therefore, angle AED is congruent to angle CBA. Let's see if that works. Return to your main screen after you've finished angles with transitivity. You're now going to work on midpoint 2 on your own. I'll give you a hint. It's pretty similar to this one. It also uses the transitive property. After you've finished midpoint 2, you're going to do your last one, supplementary angles 2. I'm going to let you work on this one primarily on your own, but some hints. Start from the justified claim. AB is perpendicular to CD. We want to prove that the measure of angle DCA is equal to the measure of angle BCD. Start from the justified claim and figure out what that means. Well, what does it mean when I have perpendicular lines? We're going to use that twice because I want information about a couple different angles. Again, remember, if you get stuck, you can use that hint button on the left. Proofs are something that take some practice. At the beginning, they might seem confusing, or you might feel that what you're writing is kind of obvious. But getting in the habit of explaining why you know something is true is a huge part of geometry. So continue practicing these. Reach out if you have questions, but with practice, you can get the hang of proofs.